Hello, everyone, and welcome to Best Practices for Hunting Across Domains with Microsoft 365 Defender. My name is Michael Malone. I'm a program manager with the Microsoft 365 Defender team. And with me, I have Tali.
Hi, everyone. My name is Tali Ash. I'm a product manager in the Microsoft 365 Defender team as well. And today we are going to give you best practices for advanced hunting in Microsoft 365 Defender. Just to remind you, this is the integrated security experience that covers protection, detection, investigation, and response across domains of identities, endpoints, cloud applications, and user data. And with that, we'll move to the demo. So this is advanced hunting, your place to do threat hunting in Microsoft 365 Defender. The first thing you would like to ask yourself when you're coming to do threat hunting is, what data do I have to hunt for? What data is collected? What is the schema? Where can I find what I'm looking to hunt for? For that, you have first the schema tree here at the left. You can see the schema tree is organized by different sections: alerts, applications and identities, emails, devices, and threat and vulnerability management, which is related to devices. All this information displayed here is coming from the different Microsoft security services covering the different domains of identities, endpoints, cloud applications, and user data. In the alert sections, you will find all security alerts coming from Microsoft Defender for Endpoints, previously known as Microsoft Defender Advanced Threat Protection, Microsoft Defender for Identity, previously known as Azure Advanced Threat Protection, Microsoft Defender for Office 365, previously known as Office 365 ATP, and Microsoft Cloud App Security. All the rest of the sections include data by the products. You can understand that emails, for example, all the email data set is coming from Microsoft Defender for Office 365. If you would like to learn more about the tables, you have two ways to do that using the schema reference you have here. And you can also expand a specific table. You can get a view of all the columns and get to the schema reference from here. We'll start from this button. It will list you all the different tables in advanced hunting. We can also search. Let's look at identity directory events. It will open us the documentation for this specific table. For each table, we can see its title, the description. We can see that in identity directory events, you can find all related events collected by Microsoft Defender for Identity, monitored on your on-premise domain controllers, your on-premise Active Directory. You can see the section of the columns, which gives you a list of all the columns and description per column. This view is actually identical to the view you can get from here. If you hover a column, you get the same description. And there is also the section of the action types. For all the tables that are logging events monitored by one of our services, you will have this section which lists you all the different event types you can find here. So you have a complete list, and for each action type, you can see what does it mean and by the description. And you can even click on the action type if you would like to explore what the SMB session means to get a sample of the data. You can click on that, and the right filter of this action type will get added to the editor. And we will run it to see sample of the results. And we can see here a sample of 3 events, all of them of SMB session action type. We can see what was the domain controller that this SMB session activity was against to, the IP of the domain controller at the time of the activity, the destination port. We can see which account initiated this activity and some details on this account, its different identifiers, what was the source device, where this activity came from, that the account logged into, and also the source IP address and port. You can also get to the schema reference, as we said, from the table itself. And So if we'll drop down, you have here the section of sample queries, which is actually one of the most important sections here. For each table, we provide you suggested queries you can start use and play with to get familiar with the data in the table. If you will hover the name, you can see that group modification will give you a list of changes made to a specific group. You can click on that, and the relevant query will get added to the editor. In this specific query, we are using a variable. We need to insert the name of the group we would like to monitor. So let's look for group modifications on the domain admins group. You can see, I will run it at the background, and you can see we're using the extend operator in this query. In a second, we'll see why. Most of the tables, we have the additional field section, which is a JSON containing different attributes that are relevant for the specific activity type. Therefore, it is not exposed in its own column. And if we would like to extract important information from the additional fields into its own column, we can use the extend operator. For example, in the group modification event, group membership change event, we can see using the to group that we are talking here about addition to the group and not removal. And if it was removal, this key was from that group. Therefore, what I'm doing here is we are getting the to group extracted from the additional field JSON into its own column, the same from to the from group, and we can see here those two columns, and we can see that this specific activity was an addition to the domain admins group, and the account that was added is more, and we can see that this change was made against the domain controller MTP RDC01, and the account that initiated this change and added more to the domain admins group is Matt. So this is a brief of the different information you can get from identity directory event table and how you can easily find the data you are looking to hunt for using the schema reference, the document each table. Let's move to the next data sets of emails and explore a bit this one. In the emails data set, we provide full information of the email transactions, including what happened to the email during the delivery, what happened to the email post the delivery. You can find it in the post-delivery events table. It includes manual remediation actions that might have taken on the email or automatic actions. Sometimes Microsoft Defender for Office 365 identified the email as a malicious after it was delivered and taking automatic actions to remediate that. So with email events and email post-delivery events, you can have a complete view of what happened to the email transaction. And we also provide information on attachments and URLs included in the emails. So in this first query, we would like to recognize if there were any emails that were recognized as phishing or malware during the delivery, but was delivered to mailboxes in our organization. In the email events table, we have the columns of phish filter verdict and malware filter verdict that give us this indication. And we also have the column of delivery location where we can see if the email was blocked, junked, or delivered. And we would like to see if there are cases that although the emails were recognized as phishing or malware, got delivered to the mailboxes and will need to take extra remediation actions in this case. So we can see a bunch of emails. All of them were delivered, although they were recognized as phishing email. And we can see different information on those emails, the timestamp they were delivered, the sender, or the recipient that got them. And we can see that all of them including attachments. Another interesting thing is that all of them came from the same sender. So from now on, we will recognize this specific sender as our malicious sender, MTP demos@juno.com. And now we'd like to get more information on the attachments. Since those emails were delivered, it might be an option that some of the recipients actually downloaded the attachments that might be malicious because the emails were recognized as phishing. So what we'll do, we'll query the email attachment information for all the attachments came from this malicious sender, and we will join it together with the device dataset, device file events table to see if we found any activity on the device involve this file. And we will use kind left outer join to make sure we have for each attachment what happened with it, even if it was, if we saw a correlated activity on the device or not. And as we can see here, we have 2 activities of emails and attachment that were downloaded to devices in the network. All the rest of the recipient didn't download it, which is good. It means we need to focus on those 2 recipients, on their devices, and maybe remediate them. So we can see here it actually the same attachment that was downloaded. And we would like to learn more about this attachment. And using advanced hunting, you can do that because we don't provide only raw data information. We are also trying to enrich your hunting and share with you from the threat intelligence we as Microsoft collect. And we provide this information using functions. Our first enrichment function we share is the file profile, which gets as an input an identifier of the file. It can be SHA-1 or SHA-256. And it gives you more information you can learn on the file, like its global prevalence, who signed it, who issued it, is it executable. So what we'll do, we'll take the different identifiers of the attachments we received from the malicious sender. This time we'll use the default join. It means we'll get only attachments that were downloaded to device in the network. And we will invoke the file profile on those attachments, on the SHA-1 of the attachments. Okay, and we can see here the enrichments for 2 files. The first one is the file we found on the device, and we can see here the file size, when it was first seen globally, when it was last seen globally, and the global prevalence. And the global prevalence is quite low, which is even more suspicious. So we started from looking for emails that were recognized as phishing, but were delivered to the inbox. We found that some of the recipients that got those phishing emails downloaded the attachment into their devices. And we see here that the prevalence of the file is low. We can conclude those files are malicious, and we would like to make sure that they will not be on devices in our network. And we would like to remediate them. And we can easily take remediation actions directly from advanced hunting. We don't need to go anywhere. We can do it directly from the query results app. So I was just running the previous query where we have the information about the attachments and the devices they were found on. I can choose which records I would like to take remediation actions on and click on Take Actions. You need to have remediation permissions in the tenant in order to take remediation actions, and we can see the different remediation actions we provide on the device and file. And in this case, we would like to quarantine the file. We will choose the identifier of the file and click Next. By default, it will extract all the different files and the devices in the record that we chose. And we can see here the 2 devices, and in the target entities, the identifier of the file and the device. If you would like to change what we are doing, we can select and unselect it. And then in the summary view, again, we see the same information to make sure this is what we would like to do. Once we submit the actions will get triggered on the impacted assets, and you can see the full remediation status of the entities in the Action Center of Microsoft 365 Defender. Before I'm heading it to Michael, I would like to share with you another feature we have in advanced hunting, which is the ability to create custom detection rules. In this case, we find a malicious sender, and let's assume that we would like to get alerted anytime we receive in the future an email from this sender and it is delivered to the mailboxes. So I created a query that is doing it. We are filtering for the malicious sender and the action is delivered. I will just clean the rest of the window so the custom detection rule will be made only from this query, and we can create the detection rule. We need to provide different information on the rule itself and the alert. We need to set the frequency when we would like this alert to run. At the first run, it will look for the last 30 days. We can choose that it will run every 12 hours. We can provide the alert title, what is the severity of the alert, what is the MITRE attack category of this specific alert. So we will choose initial access and the technique of spear phishing attachment. In the description, we can have a description. We can also add recommended actions if we would like the analyst to see it. Then we'll choose the impacted entities. In this case, it will be the recipient that got this email. So we choose the recipient mailbox, but also the object ID, the Azure ID identifier of this user in the cloud. We can set remediation actions that will be applied automatically once the alerts are triggered. In this specific case, we'll have only the user actions available because device and file are not relevant. So I can set to mark this user as compromised of the recipient user anytime this alert is triggered. So this user risk will become high and all the conditional access policies you configured will be applied just in case. And at the end, you get a summary of all the details of the rule and the alert, and you can create it and the rule will run. And with that, I'm heading the mic to Michael.
Thank you, Tali. So we've been talking a lot about phishing and tracking phishing activity. And one of the things you commonly deal with phishing is going to be URLs. So I want to talk a bit about the Parse URL function. Parse URL is going to take a URL and break it down into its individual parts, including each of the query parameters. Now, if you remember from our session tracking the adversary that we just finished up a bit ago, we talked a bit about dynamic objects. And dynamics are basically when we have a JSON object in a query result that we can then break out using a function like bag unpack. If you haven't had a chance and you're sort of new to advanced hunting or you're looking for some new skills, definitely check out our session tracking the adversary. So bag unpack is going to take this information and promote the first level of the columns. So we can see in here that it was an HTTPS connection to www.bing.com/search as the path. This is essentially the URI stem. And you'll see all the individual query parameters are out here as well. In this case, we were searching for tracking the adversary with MTP Advanced Hunting. So let's talk about using some of the capabilities of Microsoft Defender for Office 365 to track phishing in advanced hunting. So we're going to start out by checking the email events table. So if you remember, the email events table is going to have one entry for each email that was processed by Office 365. We're going to filter that down to where we saw a phish filter verdict of phish, which means the phishing filter said this is likely going to be a phishing email. We're going to bring in the email URL information. So this is going to be every URL that we saw inside of the email that came in that was picked up as a phish. And we're going to use Parse URL to break out the host. Last couple things here is we're going to make sure we parse everything correctly. So we're going to remove any empty rows. And then we're going to go ahead and make set. So now make set is a handy operator that will take individual rows and pack them up into a JSON field. So this is another dynamic. So if we take a look at this query piece by itself and we run it, you'll see all the individual URLs that came back from an email that was marked as phishing. You'll see all these different crazy looking URLs in there. It is worth noting that it is entirely possible that a phishing URL is going to, or a phishing email is going to have a legitimate domain in it as well. So you may want to perform some filtering if you're doing this inside your tenant. The second thing we're going to do is we're going to pull this together with device network events. So this is going to be where we have Microsoft Defender for Endpoint on a device, and it makes a network connection out to a destination host. We're going to start filtering where we see URLs. So this is going to get where the URL is blank. So it should be like an IP connection, for example. And then we're going to use Parse URL again to grab the remote URL field and get the host out of it. So now that we have Parse URL hosts for both of these, we can compare them on equal terms. The next thing we're going to do is we're going to take phish URLs, which is going to be the value we set up here to all of our individual URLs that came back from phishing email. And we're going to extend it out into so we have one column for each of the individual rows that has all the URLs in it, and then use MV expand. So from tracking the adversary, we talked about MV expand, which essentially takes a single row with multi-values, such as we have with our JSON set of URLs, and it multiplies them. So if you have 5 items in the set and you have one row and you do an MV expand, you're going to have 5 rows, one for each of the items that comes back in the set. The last thing we're going to check is we're going to make sure that the network event host, which is the host name that came back from a device network event, matches the phishing host, which is one of the URLs that came back from our phish URLs. And in this case, we can see a net HPC made a connection. In this case, we're seeing Facebook. So this is not a malicious URL here, but it was associated with one of the things we picked up as phishing previously in our query. So great example of why you definitely need to do filtering on some of the URLs that come back prior to using them for alerts and such. But it's really a handy tracking technique. Now, another function that's really handy in advanced hunting is called the bin function. So the bin function is going to create buckets of time based on a timestamp you pass in there. Now, one of the things that's really handy is many of the tables that are in advanced hunting have a timestamp associated with them, which is going to be the time that the specific row was recorded in the system. So we're going to take a look at the identity logon events table, which is going to be whenever we have a logon activity that's picked up by Microsoft Defender for Identity. We're going to make sure we have an account UPN, and then we're going to use the summarize operator to figure out how many logons we have on a daily basis. So the way this works is going to be number of logons, it's going to be the count of rows that come back, pivoted by the account UPN. So this is going to be per account UPN. And then we're going to bucket the timestamp that it was logged on a daily basis. The last thing we're going to do is we're going to use this really handy operator called render. And render is going to make a time chart for us, which is essentially a line chart with the time as the x-axis. So as you can see, we've got a couple spikes here, and each of these results that come back is going to be representing how many logins a specific account is made on a daily basis to the tenant. Now, since we have this information, let's say we wanted to figure out our most and least frequent logon users. So if we go down here and we're going to take the same techniques to summarize number of logons by account UPN, binned on a daily basis, and we're going to put it into another summarize. So the second summarize we have here is going to give us an average for that specific user principal name or account, specifically the account UPN. So total logons is going to be a sum of how many overall logons that particular UPN made in the entire data set. The second we're going to have is the average daily logons. So since we have a daily basis here, we can say for a given account UPN, what's the average number of times that we've seen that individual UPN logging on a daily basis? We can also see the minimum and the maximum. And we're going to go ahead and grab the top 10 by total logons descending. So if total logons, again, is going to be our sum of the number of logons that happened for that particular account. And last, we're going to render a column chart. So this is going to be the total logons for the PE Krebs account. It's going to be 3,894. We can see there's 749 was the most times it logged on in a day. We can also see this one over here is going to be the average daily logons for this particular account is going to be approximately 205 logons. There's also a little teeny one. I don't know if I'll be able to mouse over because it's pretty small here. But this will be the fewest log. In fact, the fewest logons is probably going to be 0 in this case for this particular account on a daily basis. Now let's talk about a new table. So the identity directory events table is super handy. It's got information whenever we have Active Directory performing some sort of, let's say, replication or other significant activities, it's going to log an event in identity directory events. And again, this comes from Microsoft Defender for Identity. So if we run this, we're going to take a look at the action type. So the identity directory events table is somewhat similar to the device events table, where we have multiple different types of events that are fit into a single standardized table schema. So what you're going to see is the individual types are going to be listed as action type. This is also available under the schema references Tali talked about earlier. One of the ones that's particularly interesting is going to be directory services replication. This means something performed a replication with Active Directory. So let's dig in and see what type of accounts and systems are performing replication attempts to Active Directory. To accomplish this, we're going to do identity directory events, where the action type is directory service replication. And then we're going to summarize the count by the IP address it came from, the device name in lowercase. This is so we have consistency for grouping. And last, we have the account UPN. And we can see that there's this MTP Air AD Connect 01 system. In this case, this is not terribly interesting to us because this is going to be your Azure Active Directory Connect system. So we would expect it to be replicating with Active Directory. However, we also have replication attempts from Annette HPC using Eric Gubby's account, and we also have some from Barbara M using Barbara Morell's account, and we also see some here for Ann Hill's account. Now, seeing that these are coming from workstations, that's sort of suspicious. So let's dig into it further. what we can do is we can use as identity directory events where it's replication and filter out our MTP Area AED DC box because we're not interested in the Azure Active Directory replication in this case. We're going to join it with the device network events, which is whenever we have an inbound or outbound network connection or attempt from a device that's monitored by Defender for endpoint. And we're going to join together using the IP information because we've got the source and destination IPs and ports. So that's a pretty unique identifier for a network connection. As you can see, we're joining it where the left IP address is equal to the right IP address, a local IP, pardon me, and the left port is equal to the right local port. So this is taking, and again, this goes back to our tracking the adversary session. The right columns are coming from the device network events table because it came after the join statement. The left columns we have here are coming from the identity directory events table because they came before the join statement. Again, definitely check out episode 2 if you're new to joins. The last thing we're going to do is we're going to reorder some columns. This is just for visual reasons. This makes it so that we can prioritize the columns and move them left for the ones that we're most interested in. And as you remember, so timestamp 1 is going to be the timestamp from the right table. So what we can see is when we dig into what is performing these directory services replications, based on that networking information, looks like we might have Mimikatz out here because Mimikatz is a particularly concerning application to have on our network. It's a credential theft tool that's commonly leveraged by targeted attackers. So what I'm going to do is I'm going to go to the device network events table, and I'm going to grab it where it has the Anet HPC or the Barbara MPC, and the file name is Mimikatz. So it's not the most perfect way to get to find it in the environment, but it guarantees me I'm going to get back a result. Now you'll notice here under file profile, I'm specifying initiating process SHA-256. This is because the device network events table does not have a SHA-256 column. It has the initiating process SHA-256 because that's the process that initiated the network connection. The last statement down here is going to be a project reorder. This just helps us visually. We're going to prioritize the threat name, global prevalence, global first seen, last seen, and initiating process folder path so that we can very quickly analyze the results. And sure enough, when we take a look into it, we're seeing a couple different hashes here, it looks like, but they're concrete malware determinations. This is, in fact, Mimikatz, our credential theft tool. The prevalence, once again, we've got a one with 139. So this has been seen 139 times in the world. And we've seen this one over 5,000 times in the world. And if you click on any of these, we can even see in this case, it's been launched by PowerShell. So this is something we're going to want to dig into using Microsoft 365 Defender's incidents and such. So that covers our demo for today. Definitely keep in touch with us through our security community and check out our GitHub. We've got a really great GitHub that has a lot of advanced hunting queries for Microsoft 365 Defender. Thank you for watching our session.
We hope you find this information valuable, and we hope to see you next time. Enjoy your hunting.
Happy hunting.